In this lesson, I want to show you how to create a flower pattern. First, by manually specification of the bending sequence, and then by automatic creation. For this lesson, I will use the simple U profile from the first lesson. I switch to flower pattern view, and I press the chain button to switch to create a new pass, LO2. The content is copied from LO1. Now I open the toolbox Modify, select the arc segment, and modify the arc angle by pressing the arrow button to bend it open. Now let us have a look at the flower 3D. You see the band edge is longer than the web length. Forming this way could cause problems. If the longitudinal stress exceeds the yield stress of the material, you get remaining strain and unwanted deformations. Some examples of this are shown here. So it is a must to check the stress. Open the window, stress of band on bench, and you see that the stress between LO1 and LO2 is 34%, related to the yield stress of the material. This is okay. I leave the window open, and I will repeat this for the next passes. Create the next bend. And you see how the bar grows and shows the stress in a clear way. Take care that the bar does not touch or exceed the yield stress of 100%. Creating the bend angle for each subsequent pass while observing created stress. It's a good idea to bend progressively less approaching the final pass. The flower pattern is ready now, and the stress is okay. This profile requires 7 machine stands. Pass 08 is not a stand. It represents the flat sheet in the machine entry. This flower pattern of a C profile has a problem. You see the red lines. The longitudinal stress exceeds the yield stress of the material. What can we do to solve it? Option 1, more stands or another machine, quite expensive. Option 2, distribute the stress more equally over the stand. I will show it. Select the pass, select the angle, and adjust. Repeat. This is better. However, only possible if the stress is below the material yield limit. Option 3 is centerline forming. In this feature, the profile web, the bottom of metal, is lowered from pass to pass. The centroid of each pass is on the same level. This creates shorter routes of the band edge and lower stress. Before I decide for this option, I will check if centerline forming would solve the problem. Using the checkbox. It does. Now I will proceed with this option. Select Profile, Centerline forming. 100%. This means lowering the centroid. And we have the centerline forming. However, the machine must have adjustable top and bottom shafts for this option to work. Another example of centerline forming is used in tube forming. The incoming flat sheet is on the level of the outgoing tube center. This program has a very important design feature, the selection of the right bending method. This is defined by the number behind the A. It is necessary to define it before creating the flower pattern because it determines in which way the arc is created. A1 is a constant developed length method. I select the angle and the radius is calculated, or I select the radius and the angle is calculated. This method is often used for small radii like the U profile in our exercise. A2 is a constant radius method. I select the angle and the developed length is calculated. Because the total developed length, the strip width, must not change, the previous line segment is corrected. This method is used for large radii, like round tubes. A3 works like A2. However, the following line segment is corrected. This also is good for large radii. A4 is for specialist, the track holding method. It combines A2 and A3 and is good for reusing roles for new projects. Another method for experts is A4 extended. Because a part of the neighboring line element is first bent and pressed back again, spring back can be compensated. Without overbending, the pressed back section springs back in the opposite direction. Next, I will show you how to create the flower pattern automatically by using the development table. Here is our project from the last lesson, the bumper. Imagine this bumper ran successfully on the machine, and you want to use the bending scheme for a new bumper with different dimensions. Here, shown in CAD. Some lengths, angles, and radii are different. I open the development table. It is empty. I fill it with the data of the old bumper. Now, I save the file. I close the development table. Now I empty the project so I can load the new one. I import the drawing of the new bumper from CAD. I set the start and end point, and I create the project. I make it symmetrical by appending the last event, adding PS. Now I open the development table again. And open the table that I saved from the old project. Because the new project has different bending angles, I recalculate the table to percentage. The percentage is generated based on each final angle. Now, I use this table to create the new flower pattern automatically. Here it is. The bending scheme is taken from the old bumper. By this means, the designer's know-how is transferred to the new project.